Hello again, and this is the video for the grading of the crescent wrench. So what I often do is I start with the assembly, but I'm first going to show you the, well, yeah, I think I'll just start with the assembly here. And uh, this is what it's overall supposed to look like. And what I really usually do is start with the motion study because sometimes that's the most likely place that it breaks. So I want to make sure that students get credit for going as far with it as they can. So I just go here and hit play, and hopefully it does exactly this kind of thing. If you actually get closer here or further away there, that's fine as long as it does this. Now, sometimes it gets kind of broken and choppy because of the way it calculates things. Mine is all nice and smooth. Uh, it don't worry about it too much. Don't fret. It's not worth all that time and effort. If you got it to do something like this, I'm reasonably pleased with that. So since I'm on the assembly, I'm just going to go here. Don't worry about these two; they come later. And going to look at how it connects up with the assembly file, and then we assemble the, let's see, there we go, the set screw, and then the handle with the thumb worm gear. There it is. Okay. And more on the worm gear. Finally, we place in the adjustable jaw, and then that tangent, which is the real bear. Sometimes that's the one you want to work with. Sometimes you have to delete it. Sometimes it just helps to suppress it, and then um, unsuppress it. Sometimes you can do this, and then you unsuppress it, and it recalculates it maybe in a different way, and maybe that'll help work out. So then hopefully it will do something like this. All right. So that's the assembly. In some ways, that's the that little bit, and the motion study, the hardest part. So I want to make sure that all those parts are together in the right ways. If you have extra mates, that can really cause problems. So you have to get down to the bare minimum number of mates, and this is pretty much it. Might be even fewer that you can work on. There might be more efficient ways of doing it, but you certainly don't want more. Okay, so now I'm going to go up here to worm gear, and I'll actually go to, instead of going in order of events here, I'll go to the handle, and there we go. So make sure that before you start, you do these things, assuming you're on this video, that you haven't done that, but make sure you go through all of this guidance. This is here to help you so that you can get done faster and get better grades and all that. That's just a reference drawing, may or may not help. And then we've got the checklist, and down below here, I'm going to have this video, but obviously since I'm making it, you can't click on it yet. So, all right. So here we are with the handle again. All right. So the first thing I'm going to do is I'm going to open up all of these sketches. So if you do this ahead of time, that makes me happier. All right. You don't have to worry about the ones up here, but all the sketches. I'm going to look around for the correct dimensions, anything that looks weird. Sometimes people have issues with this and the 220 going to the tangent. Maybe they put it to the wrong spot, so it looks similar but not the same. Uh, so making sure all the dimensions are correct, got the right shape. All right, good to go. And the notice how I put the origin right here, and you'll understand why if you don't already by looking at the assembly. All right, so then I'm going to look at the draft, make sure it's going the correct direction. You want it to kind of taper upwards on both sides there. And then we create this little point plane. So that point is right there, plane there, and then we do that cut revolve. Yeah, and that cut revolve's kind of a pain, isn't it? Yep. Hope it worked out for you. Then we mirror that. Once that's done, mirror shows up. And then there's this plane. This plane is actually pretty important. Or is it the other? I'm sorry, it was plane 3 that I was talking about. Okay, so then plane 3, plane 4. So then what I do with plane 3 is I adjust it, because this plane 4 is dependent on the angle of plane 3, which is at 22 degrees. So I just have fun with that. I change it to 25, and I follow to see if everything else has followed with it. Watch the handle. Okay, the handle comes up like this. It wrecks the fillet that was going around here. You'd hope that it would go here, but I guess it doesn't. And then I do that same thing, and I change that 25 to 20, and watch the handle go again, back the other direction, and that fillet still doesn't come around, but that's okay. Everything else, nothing else is broken, nothing else is weird. And so then I just undo both of those. Yep. All right, so now that plane is back to 22 degrees, where it's supposed to be. Those fillets come up here, those fillets come there, and all is well. Now, if it was a little better design, maybe those fillets would actually continue on, but at least nothing else breaks. So I'm going to go to this sketch, going to make sure that that dimension is going all the way from this plane all the way down to the tangent. We've got a radius of 50 here. Sometimes people make like a radius of 1 or something different. I don't know why, but there you go. All right, now it moves a little faster here. We've got this cut on this side. And then it mirrors. Lots of mirroring here. Then we have the loft. Now we've had it all set up. We got this sketch here. Sketch here. Could have used the surfaces here. Yeah, sure. And then that one. But I kind of liked watching how they all look in this particular view. All right. All right, so there's that fillet that goes everywhere here. And it's what size? Like 0.03. And then this one is 0.43. There's a little different fillet here just to get a smoother edge there. And then we cut this big hole for the worm gear. Put the fillets in the corners first so that our second set of fillets, or the fourth set, I guess, just goes around nicely as a tangent propagation. So the order of events is important. All right, then we make, looks like a keyhole, a slot for the jaw to slide through. And so it's exactly 0.5 top to bottom, 0.31 diameter here, and 0.16 across. That's how it's all symmetric. And this one, notice how it's the sketches in the middle, and then it extrudes, and extrudes specifically to these two surfaces. All right, now location of this hole is important, but pretty easy hole to do. And then, as you may have seen in the guidance there, this hole should not have a counter bore. When you put this in, it might have this box checked automatically. This one down here, where it says near side, make sure that's unchecked. Yours might look like this. Don't want that. You want it like that. And then you're all set. All right, and so the handle is the biggest deal of this whole situation. All right, so let's go to the here's the set screw. So this is the you know, all the guidance on the set screw, and make sure you go through these bits. And then finally the checklist. Now for all of these, remember, we do not allow the minus signs or the selected contours. So make sure that these get fixed. If you don't know how, I can send you that link, or we can go over it on Zoom. All right, and here's the example feature tree as well. Okay, so let's go to the set screw. Fairly straightforward. Open up those sketches. And the key problem here that students run into is that the overall length from point to tangent is 0.96, but the arc here has a radius of 1 inch. So that means that the center of the arc is a little bit further past the point. And of course, I put the origin at the point. So this, sometimes students, are, maybe it's because they don't have a larger screen or something like that, but they put the center of this arc right here, and then they wonder why the computer yells at them. Best thing to do is to delete the arc, then make a new arc using center point arc, and make sure the center point is way out here. Then you go up here and do that, and you might have to trim a couple things, but it'll work out a lot better for you. All right, so this cut's fairly easy, both sides. And then instead of looking at the sketch, which is just a circle, look at the actual helix. So we look at the height, the pitch, and sometimes it helps to have a change the start angle up. And so that's done there. Oh, something happened to that. Lovely. All right, well, let's go find out what happened with the cut suite. Self-intersecting geometry. Well, that usually happens when our sketch is a little bit funny. So let's go to our sketch. I wonder if I changed this up at some point in time. I don't think I did. All right. This often happens when the width of the sketch here is, notice how I have 0.0312, when it's the same size as the helix here, 03125. So I want to make sure that this is correct. So I'm going to change the sketch a little bit here to 031. And it still doesn't like it. Let's see. Maybe something happened in 2019 that didn't like that. Okay. Even worse. Okay, so the problem with doing that is, as you can see, I get this little ridge here. I'm not very happy with that. So I'm going to try to regenerate it. And it gives me an error again. All right, well, hopefully you're not running into the same thing as I am, but at least I've shown you how to do it. What happens is that if this edge gets too close to itself, it becomes a like an infinitesimally small thing. So one other thing that can help you with that is going up to system options, and maybe this is what was different from when I originally did this, but say system options, and I think it's under display or performance. Image quality, there it is. All right, so if I have higher, faster image quality, may improve. Yep, there it is. Oh, sorry, let's do with the old one. Let's do it. We got. Yeah, didn't like it. All right. Well, it was worth a try. I'm really surprised because this was working just fine yesterday. Go figure. All right. So for the final bit here, we've got this cut extrude. And I think I mentioned on there that if it's not working out right for you, then okay, so yours might be a little bit off like this, whatever. You might want to delete those things, grab this, and make sure that it is collinear with that edge there. Then take this point and drag it to that spot, and then you've got all of it. And so that should work out well. Again, sometimes people have this little sliver that shows up there, and so you'll have to do that to fix it. All right. And by the way, this is why we don't make threads, actual threads. One of the reasons. A thread is a whole bunch of tiny little cuts that really don't help you unless it's really crucial. So not every screw, if you had every screw on every part with all the threads, you'd bog down your system terribly. Okay, here's worm gear. And oh, there's worm gear. Make sure you go through all the steps here and to avoid the problems and the tough parts there. All right, so I'm gonna hide that right plane there, open up all the sketches, make sure that there are no bad symbols, symbols of doom, and check the dimensions here. Now this helix spiral, notice how this should be 0.548 and 145. Hopefully by this time you figured that out. All right. Hopefully this is not going to crash on me. All right, didn't crash. So sketch, of course, is just a circle, and it's attached to the one thing, so not too worried about that. Now this sketch is kind of funky because it's symmetric, but it's hanging off the edge there. And of course, that's by design. So we look at those dimensions. And then we cut off that end. So I tried doing this a whole bunch of different ways, but this seemed to be the best in this case. So I had to cut off that end and mirror it over there. So making sure that the mirror happened and that the cut happened where it's supposed to be. And then we've got this cut extrude. Now you may have problems with this. If you see here a minus sign or a selected contour symbol here, then you should really go back and redo it or check it out. And if you do, remember how to do that. Right click on the feature, not the sketch, the feature, edit the feature, and then where you see selected contours here, just click on it and clear out all the selected contours. Mine is okay, so I don't have anything in here, but you want to clear that out. Okay, so there's that cut extrude on this side, and then we redo that again because it was so much fun the first time on this side. All right. Finally, we have that one little cut. Now notice how I often just want to cut exactly what I want, but in this case, it was just so much easier to do a circle and it was work right on the outside. And also the way it rotates it, we probably would want the circle anyway. So in that pattern, and wow, that's a lot of them. Okay. And you can see here, right down the middle, there's 100 of them. All right. So last but not least, the adjustable jaw. And make sure that you go to the jaw here, and probably might add some things in here, but got the drawing and you've got the example feature tree and some of the usual things, and question about the fillets that are in there. So we'll get to that in a second. All right, so just go to this. Make sure everything is about right. The shark fin. This feature is always weird every single time, just about. It shows that it cuts down here, but actually cuts up above there. I don't know why. It's pretty crazy. So this chamfer, I'm showing you how to do a chamfer that's not a 45 degrees. So you can specify the distances on that. And back to another draft, making sure it's going the correct direction, tapering towards the top. And then there's this block, throw on here, symmetric, aligned with everything else. And then here are those fillets that just kind of round everything out over here. And finish up with these cuts that allow for the thumb screw or worm gear to move through. All right, so then there's that linear pattern. There's 9 of them at 0.145. Then we finish off with a couple of annoying cuts that I hate, but that's okay. Had to be done. Okay, and that is what I'm going to be looking for the crescent wrench. A lot of things won't fit together properly if you don't make them right, and so do your best to move through that. If you still have questions, if you're not sure, if you think that something's not right, let me know, and we'll talk about it first before we go through a whole grading thing. All right. All right. Thanks a lot. I hope this was helpful.